Hello, this is Tristan Hill, and this is ROS Workshop Module 4. And today we are going to go through setting up your workspace and um, building a couple custom nodes. So we're going to build a publisher node, a piece of C that publishes a topic to the ROS server, and another piece of C++, I should say, that subscribes to that same topic. And we will interact with our turtle sim we've been using. So to get started, I'm gonna open up VirtualBox here. Go ahead and start my VM, and wait just a moment. Here we go. I was just waiting on that. Actually, didn't need to wait. It was in the background. And go through here. As you know, it helps to be patient. We're using a virtual box here. We're gonna get rid of that menu. And first thing we notice, it looks like display settings may have reset. So I'm gonna log in here and we will see. Okay, it looks like we're good. Just say while I brought that up, I'm in scaled mode and I've got the pixels turned to where I want them. So looks like we are ready to start the tutorial. So to do module 4, we're going to come in here, Firefox, and find the go to the in any number of ways, go to the tutorial. We're going to do 4 today. We're going to go through here to 4 and go here to this document. So, well, again, to repeat, what we're going to do today is create a custom package. So that will be a directory location for our custom code, which will represent a node in ROS to live. So once again, we're going to basically set our directory structure up and learn how to build custom nodes in C++. Okay, and we're going to do this in Noetic and Ubuntu 20, Ubuntu 20, I should say, as we have been working in. Okay, first thing we're going to do is update our system. So I'll push that over here so we can see it. Before I do that, though, I want to mention one thing about the naming. Here's the naming structure we're going to use. The Catkin WS for workspace is somewhat standard. So you'll see this in a lot of different places, and these are names that I created for this exercise. I encourage you to use them the first time, and then if you need to customize your system, modify afterwards for your needs. There are some important guidelines there, and I definitely encourage you to follow those guidelines there on naming rules. So here we go. We're going to start. Well, before we start the tutorial, let's do a quick summary of what we're going to do. It's really 3 parts. The first part is going to be setting up our workspace. So it'll be the directory structure that our package and nodes exist in. And then in part 2, we are going to create a publisher node. So again, a piece of C++ that publishes a topic. And then finally, in part 3, we will create a subscriber node, a piece of C++ that subscribes to that topic. And once again, we'll also use our turtle sim to demonstrate that working. So let's start. So when we are doing system configuration or mainly installation things, it makes sense to update the system. Today, we're not going to install any new packages, so in a way, this is somewhat of an optional step, but it won't hurt to go ahead and make sure our system is up to date. I just did this just a moment ago, so we don't see any new installations. Okay. The next thing we're going to do is make sure our computer has ROS installed. So this next line is run the ROS setup file. I will say, if you have been following the tutorials, you have already done this, and so we can see that. But if we go look at the bash RC file, it's right here. So when we turn this terminal on, this command was executed, but it doesn't hurt to go ahead and run it one more time, and this just ensures that we do have a working ROS installation, or at least a ROS that has been installed on this computer. Next step, we're going to create the directory. So this physically is make the directory with the parent option. So this is creating the directory and subdirectory, CAC and workspace for workspace, and source for the place our packages will go. So the source of our workspace, if you would. So we'll paste that in, and we have created a directory at home. So now we can see if we do a list our current directory, we're here at home. We now have this new leaf form directory, cat and workspace. If we wanted to look inside of it, we could look inside of it, and it has this empty folder source in it. Okay, now the next step is going to be move into that top level of our workspace. So once I'll again refer to this location, Catkin workspace, as top level of your workspace, and that is the place that we compile from. So then the next step, as you can see right here, is to run catkin make from the top level of our workspace, and we see the compile process. We don't have any code in there to compile, so it was relatively short, but it does verify that our workspace is set up. Okay, now that we have that, we can move on. A final or an important step when setting up the workspace is telling our system, Ubuntu, where the workspace is. And this is going to add a second line to our bash RC as we saw earlier. So if we just copy that here, go ahead and put this in here and run that bash RC to make sure it's still working and to apply the changes we made to it. Now we have told our system we have ROS and we have a workspace at this location. So that's important for our next step. And also something to point out is that if you were to have multiple locations or multiple different names for your workspace, this is the line you need to change to indicate that. So that's an important one, telling our computer what workspace to use. Okay, so again, you could go look in there if you wanted to. Instead of using gedit, I'll just show you with cat. We'll just go look, there's a bash RC, and now it has these two lines at the bottom of it. We put that one in there earlier, and we put that one in there today. Okay, so once again, our package path is now going to include that location. So let's move on to part 2. And in part 2, we're going to create a publisher node. So the first thing we'll do is we'll move into the source directory. By the way, we could use this command, and this uses the absolute path, the path all the way from home to where we want to go. Or I could just go into that directory. So now that's effectively the same. But what if I was like all the way at root or something? I could take the absolute path to the source directory of my new workspace. So there we go. Now that we're there, we could create a package. So it's important to know we create packages at this location because this is going to create a new directory. And so our current directory, when we run this cat can create package step, matters. So just to repeat, we're going to create a package and it wants to be in this source directory. So it matters where our current directory is when we do this step. So take this step, paste it in here. What this step does is creates a package with a name, tutorial 4, so you're choosing a name, and with 3 dependencies, the standard messages, which is topics, and ROS Pi and ROS CPP. So we run that and we see some information, and now we can move on. So the next step is that we've added a package. We could go ahead and do a compile. It's a good idea to do that, even though there's still not any code in there. So we could either use the absolute path, or watch this one, we could just go back to the workspace. So as long as we are at the top level of the workspace, we can run a catcan make. Go. Now you can see we have a package that was recognized and compiled. So now that we have a working package, it can house a piece of code, which is what's behind a node, our first custom node. So what we're going to do is we're going to open a text file with our default editor gedit. I'll go ahead and full disclaimer, not quite my favorite, but it's a decent place to start. And so we're going to copy that code in there. And this is the publisher C++ code. Okay, there's a lot going on to do a relatively simple thing, but a few things to note here. Here's the, the libraries we're going to use. Here's the name of the node this code is associated with. So note that. Here is the publisher, or the thing it's going to publish. So there's the data type it's going to publish, or the message type, I should say. And then this is the name of the topic. So one of the important things I want you to point out to you is here's the name of the topic this code publishes, right there. And here's the math that it does. And in a little while loop in C, it increments a value, updates the value of this object attribute X, and then publishes it as a ROS message under this topic name. So there's your code. So after you've copied it in there, make sure you save it. So make sure the star goes away, and you could leave it open or close it. So for the exercise, I'll go ahead and leave it there. Oh, and actually now I misspoke, because it's occupying this terminal. I'm going to go ahead and close it there. It's a Control C. So we're getting close to the end of part 2, but there's a few things we have to do to tell our workspace that C code needs to be compiled. So we're going to go in here and we're going to edit this CMake list file, and it is a file associated with this package. So if you notice, it exists inside of this package. So this is the CMake list for this package, and we're going to stick these lines in there and put them down here at the bottom, those down here, and save it. And notice what these lines do is add Turtle Sim Publisher as an executable and link the libraries. An important thing to point out is that will be the name of the executable, how we'll use it, and here is the directory location. So a common mistake might be either putting the file in the wrong location or telling it to compile from the wrong location. Again, that is the relative path from the package tutorial 4. Okay, so now that we have made that change, we're going to save it and close it. We get our terminal back, and we're going to go ahead and compile. So now we would expect our C code to be recognized and compiled. And so now we've seen something else is happening. We're seeing this compile process is starting here, and we have a successful compile here, or full build. So some of the, you might not understand everything that's going on here, but if you read, and you can read and learn about it. But if you do see a failed compile, you'll see some red ink and some errors here, and we can get some information from that. So this is a successful compile. Okay, so now we have compiled our code. We would like to test it, and that's the kind of end of part 2. We'll be testing this, and so we're going to need let's look at our test process here. We're going to need a few different terminals. We're going to have a core for our start terminal. We're going to run a Turtle Sim, and we're going to run a publisher, and then we're going to run a list. So that really looks like it's going to be 4 4 terminals. So I'm going to go ahead and just get a tab and a tab and a tab. We'll kind of start from the left to the right. Let's go ahead and here, we're going to have a ROS core going here. And then take this one and we'll get a turtle here, turtle there. And let's maybe bring it, we'll bring it back up in a second. So now we're on the third one. We'll go this one over here, put it in. And if we go back, you can see our turtle is doing a motion now because it has subscribed to the turtle knows to subscribe to a topic named turtle1 command velocity, and our publisher is providing that data. So to repeat, we have a core, we have a publisher, we have a turtle node that was waiting for a topic, and then our publisher published a topic which caused our turtle to drive. Okay. And so the fourth thing I would encourage you to do is practice using the diagnostics tools. They may seem auxiliary or not important, but it's really very important that we can now go look at some information about those topics. So let's bring it back and watch it. But here's a couple important ones to note is you can, at any point, list them all, and then we could listen, or we can do an echo, which is observe that topic in time. So what's happening, the x is being incremented, the angular velocity stays constant, and that kind of gives us this growing spiral. Okay, so I could close that. Another one that I think is very important, but I don't talk about too much and is useful is this. When you look at the other ones, you can do, I'll just go with it. You can look at the frequency of publishing. So for certain debugging events, this is a nice one. You can say, oh, look, this one is being published at about 10 hertz. And we can match that up. That is associated with where does that number come from? Well, the 10 hertz that we asked our C code to publish at. So another real interesting debugging strategy. Well, there's a lot of debugging tools in ROS topic. 2 of them that I just showed, echo, show the message, and then hertz, show the rate of the message. And they're very useful. Go check out those others if you have time. Okay, so what we've done is gotten through part 1 and part 2, which were set up a workspace and then set up a custom C++ publisher node. So we'll wrap up with part 3, and we're going to create a subscriber node. And we could we could probably leave all this on and do this thing and add it to it, but I think for sake of understanding, it would be nice to turn everything off while we're doing part 3 and start it again. So I'll shut this off. I'll leave my terminals open because I know I'm going to need a set of them, but I'm going to go ahead and just make sure everything is closed. Oh no, I hit the wall. That one's closed. And you could leave this on, but for fun, we'll go ahead and turn it off. And if your VM's, kind of a little note, if your VM's struggling while you're doing some things, you can turn off some things you're not using. Okay, so part 3 will be very similar to part 2 in the sense that we are making some new code. So let's do that from here, and we can go, we're going to gedit some new code, but this time that code is not called publisher, it is called subscriber. So get your typing right or do a copy and paste, subscriber. Okay, so now we have a little blank text here, put this in here. Oh, put that in here and make sure you get the whole thing. Sometimes it's easy to lose the first or last character. So we have our code, our source code, and do a save on that. And a couple things to note about this. It's also kind of a lot of syntax to do something pretty simple, but it's not too bad. We have the name of this node. So this node will be called subscriber, and it makes sense for that to match the name of our source code and executable. So there it is. And here is our, again, topic name. So this being the subscriber, it's going to listen or get this topic. And when it does, a callback function is executed. So another important thing to note about this code is, look, you have the name of the callback that's going to be executed when you get the data. And here it is defined up top. And it's just a twist message, which is a kind of abstract motion or a ROS message. And then we can get that message in here and print the X attribute there of that message, and we're using a pointer access there. So in summary, this little C code that accesses the data that is in that topic. So what we should see, what we expect to see once this code is working, is a string I heard and that same incrementing X value that we looked at previously in the part 2. Okay, so that's saved. Do a save. We're going to close it, and we're going to similarly add the 2 lines to CMake lists to tell our workspace that it needs to compile that source code, and make sure we get this in here right. Turtle sim subscriber. Here's the location subscriber all the way with the file extension, and again, here's the name of what it's going to be called as an executable. So save that. Go ahead and close it, and again, move to your workspace, catkin workspace here, and do a catkin make. And okay, once again, we have a successful compile or build of the full workspace. We can see that we have the publisher node successfully built, and then we also have the subscriber node also built. Okay, so next we're going to test, or finally we will test. We'll have a core, we're going to turn on the turtle, and this time we're going to publish again. And notice we've published with this turtle1 command velocity remap, and then we're now going to subscribe. So let's go ahead and do that. I'm not going to paste that. I got to type that one. ROS core. That one in here. Come over here, and I'll go ahead and turn on a turtle. Looks like we got a turtle with skis this time. We're going to do a publisher. Let's see, our turtle's doing its thing, and now finally we'll come over here and let's clean that up first and run a subscriber. And now we have, let's get our turtle back so we can see this is again the line of code we saw in our C that we compiled, is saying the callback function was firing upon successful subscription and receiving of a topic. So we have that full connecting from our, again, publisher to our subscriber. So there you go. We have successfully completed module 4. And so to wrap up, we can just go ahead and close these, go ahead and close these, and you've done it. So good job. For bonus, you could turn on joystick. And so I know you can do that. Go have fun with that one. All right. Thanks for watching. I hope you have a good day.